Hello and welcome to this video for multi-platform software development. Today we're going to be looking at working with interfaces. Our goal is to decouple the ViewModel away from our storage services. Let's get started. So we're starting with this app in its current format. We have data being read in from a JSON file that's populating this collection view. And the collection view also provides us with ways to edit existing records as well as remove those records. For example, if we want to edit the number of tables in this invoice item record, we can click the edit button here. We can change the description, the quantity, and the price. So let's add another table. Now we've updated the quantity to 4. You can see how that record reflects that update here. We also have the ability to remove records by clicking on the delete button and choosing yes in the confirmation. I've added a functionality to be able to add new invoice items. When nothing is selected for edit mode, we can fill out the form here. For example, we want to buy 3 rugs at $50 each. We can fill out the form and click on the Add New button to add a new record into our collection. So we have all of these operations in place. However, the data is not persisting at this point. We're using the JSON file as a source, but we're never writing any changes back. So all of the changes are only being manipulated inside our observable collection, which is stored up here, called invoices. Currently, we're setting up invoices by loading it via a JSON service. And then when we want to make changes, we're only making changes to the local collection. So this is where we're going to make changes to existing invoice records. And our add item task is where we're going to create new items and add them to the collection. And finally, our delete task removes a selected item from that collection. So we want to modify this so that we can apply any type of storage service that will allow us to perform the 4 actions that we are trying to perform on our data. That is, retrieve a collection of all of the items, add an item, remove an item, and update an item. However, we don't want our ViewModel here to be tightly connected to any one type of storage service. We want to be able to move from a JSON service to a database service to something else as well. So we're going to start by creating an interface for a storage service and writing our ViewModel to just work with that interface. We'll deal with the implementation of the interface later. So I'm going to start by adding in our services folder a new class that can operate as our storage service interface, storage service. Now this thing is not going to be a class. Instead, we're going to have a public interface. And this interface is going to provide us with, right now, 4 methods. Typically we do 5 in a database service, but in this app we're only using 4. So we can start with 4 methods and always add later if we need to. So we're going to start with our 5 standard methods for database access. We want to be able to retrieve an entire collection of items. We want to be able to retrieve one single item based on its primary key or identifier. In this case, it's our invoice items ID property. And then, of course, we want to be able to insert, update, and delete individual records. So we can create 5 methods, method signatures, to represent those actions. Now we're going to write this storage service in a generic way so that it works with any class types. If we want to be more specific, we might want to make our interface work with class types specifically that have a default constructor so that we're able to construct the new objects when we want to retrieve them from the database. So we're going to create these all asynchronous tasks. The first one is going to retrieve for us all of a certain type of record. So this is just a method signature, it's not an implementation. What we're saying is any type of service that wants to be used by our view model, that wants to act like a storage service, has to implement some way of getting a list of items. We also want it to implement some way of getting one single item. So we'll have a task that just returns one T object. And then we have our 3 action methods. And all of the action methods should return an integer. We can use that to indicate how many rows were affected. If we're doing a database query, we can use it to send back a 1 or a 0 if we're doing like a true-false kind of outcome. So int is pretty powerful as far as what we can return for this. We want to be able to perform an insert of a new T item. We want to do update and delete as well. Here are the 5 things that we want any type of storage service to be able to do. So now that our storage service interface exists, let's go back to our view model and implement it. So inside of our collection view model, we're going to use dependency injection to take in an instance of our storage service, whatever type it may be. But what we need for now is just a local reference to some sort of storage service. And because we're working with invoice items, we're going to specify invoice item as the data type that's going to go along with it. We'll just call this thing a generic storage service. And when we take the dependency injection, we're going to take that in as an input parameter and assign it to our local instance. We're going to make sure that happens first before we start loading the invoice items. Now that we have a reference to our storage service, we have to think about where we're going to need it. The first place is when we're loading the invoice items. So previously we were loading our invoices from the JSON service, but now we want to be able to load our invoices from the storage service, whatever it may be. So just as a reminder, we'll bring this out and over here. These are the things that our storage service can do. So we're interested in getting all of the items. The items are going to be returned in a list. So I'm going to store that list in a variable, and then we'll use that list to set up our observable collection as we did before. So we're expecting here a list of invoice items that will come back from our storage service. And we're going to ask our storage service to please get all the items. So when it returns the items, we're going to store it in this list, and then we're going to use our list to populate our observable collection, just as we did before when the list was coming from there. We need to await this. So we'll set our invoices collection, just as we did before. This time, the list is coming from our storage service. Now the next place where we want to interact with the storage is this method when we're trying to update an existing invoice in the collection. So right now, the way that this submit works is it creates a brand new invoice item, and we're going to look for that invoice item in the local observable collection and then replace it. What we want to do instead of all of this is after we create the new item, we want to send it to our storage service for updating. So rather than maintain the local observable collection, we're going to send it over to the storage service. And then after the storage service has dealt with it, we're going to reload our local collection here. Ask our storage service. Notice when I type await that this changed to async task. And ask our storage service to update this given item. And then we want to make sure that we're reloading our list. For now, just to keep things simple, I'm going to create a reload task. So we'll reload the collection and remake the invoices. Now we can call this method after our storage service updates. It's an async method, so we can await it. All of the other things that we do after the update has happened, that is clearing out the input form and the item to update, we could move this into the reload method as well. Just to save a little bit of time, I'm going to bypass that for now. But this code definitely could use a refactor. Now here's the next place where we're going to ask our storage service to help us persist our data. Instead of adding the new item directly to our collection, we're going to ask our storage service to store the item by calling its insert method. So both of these are asynchronous. We can use await to make sure that they happen asynchronously as they're supposed to. So we're going to call our storage services insert, and then last but not least, when we're trying to remove an item, we're going to ask our storage service to delete it and then reload the collection. Now this has highlighted a little error that I've made here in our storage service. Delete should take the entire item. When I was using the autofill, it suggested that we only need the ID, and that's definitely true. We could write a delete method that only takes the primary key value. In this case, we have integer primary keys, so we could just pass the item's ID, and that would work just as well. But I wanted to keep it similar with the other two action queries. So both of those are valid options, delete by ID or delete the entire item object. They're both going to have the same effect. Okay, so our ViewModel now is all set up for data persistence. We're going to ask some sort of storage service to delete or insert or update an existing item. How that happens is completely irrelevant to our ViewModel. We don't have to rely on any specific type of service. As long as the service can handle invoice items, then that's all this needs to know. So now our next step is to provide a concrete implementation of the iStorage service. Now we could take our previous JSON service and manipulate this so that it will work to read and to write the collection. Or we could add a new class and implement it for database storage or for another type of file storage. There's so many options. But in keeping with what we were doing in class, I'm going to add a database implementation. So I'm going to add a new class here called database service. And when we create our database service, we're going to set it so that it implements our iStorage service. Now this database is going to be set up to work specifically with invoice items. The database needs to know its data types so that it can make the tables. So we're going to have to specify this specifically is for invoice items. Once we've decided that we want to implement this interface, you can see the suggestions showing up here that we have to implement those 5 methods: get items, get item by ID, insert, update, and delete. Now, if I choose to implement the interface automatically, it's going to write all of the method signatures for us. Now, get item by ID is one that we're not using, so we won't need to implement this one, but the rest of these will need to be implemented in some sort of way. Now, I'm going to fill out this class so that it's set up to connect to a SQLite database. So we're going to add some using statements for SQLite. And we're going to create the SQL async database object. We'll set it all up with a file name and some flags. I'll just paste that code in here because we've already gone through it in class before. So the code that I've added might look familiar. We have a reference to our database connection. We have some database constants, the open flags, as well as the file name, and I've just given it the name invoices.db. Our constructor doesn't do anything. We're sticking with the lazy initialization, which means that we have to write an initialization method and then remember to call it whenever we want to interact with the database. So just as a reminder, our initialization method returns out of it if the database has already been initialized. Otherwise, it sets up the new connection to create or open the database. We're going to look to see if our invoice item table exists, and if not, then we're going to create it. I've decided not to seed any records this time, so we can create the table, and the table will be empty until we actually add something through the app. I've also pasted in this table exists async method that determines whether a table given that name exists in the database. Down below is where the implementation of our interface is. So these are our data access methods that were implemented automatically when I selected the option to implement iStorage service. These are the database methods that we need to write in order to interact properly with our view model, because these are the methods that the view model is ultimately going to end up calling. So in all of these methods, the first thing that we need to do is to await our initialization. Our next task is to return the result of asking our database to delete the given item. We've got the same kind of options happening for update and insert. So down here with insert, the only difference is we're calling our database's insert method, and then with update, we're going to call its update method. For get items, in here we want to be able to return the entire table. So we're going to ask our database to give us the entirety of the invoice item table in list format. So our database table to a list. Now the rest of these need to be made async. Now this one we could leave it not implemented, but it really won't take long to implement this because there is a database method that we can use to ask our database to get for us the item that we're looking for. So we're going to specify to get the type of invoice item. based on the given ID. So our database service class here is complete. We've implemented iStorageService, which means that we have those 5 methods available. In our collection ViewModel, all the methods that we're calling from storage service have now been applied to database service as well. So the last piece of the puzzle then is the dependency injection. If our invoice collection view model is depending on something that is an iStorage service, then we need to go into our program and add that service. So we need to add a singleton that creates the instance of our database service. However, remember our collection view model is not expecting a database service, it's expecting an iStorage service. So when we add our singleton, we need to specify that the implementation that we're using for iStorage service is database service. This is one of the cornerstones of polymorphism and inheritance. This way, if we ever want to change services and use a different type of input, for example, the JSON service, if we make our JSON service implement iStorage as well, then this would be the only place that we need to make that change. The rest of our app is not dependent on any specific type of storage device. So let's add our singleton. And when we have an interface with an implementation like this, we start off with the interface first, specify the data type that we're using, in this case, invoice item. And we'll say that that is going to be represented by a database service instance. Now, if it's not recognizing invoice item, we're just missing the using statement for it. So now when we are looking for a storage service element, it's going to be replaced by an instance of database service. That's the implementation. In our view model, when storage service comes in, as of right now, storage service is going to be represented by the database service instance. So when we call those methods like getItems, we're going to be calling the method getItems that is found here in database service. And we can do this with additional classes as long as they implement the interface. They can slide right into our invoice collection view model without having to make any changes to the view model at all. The only change we would have to make would be changing this instance to an instance of some different class. So now that the app's running, we can see we're starting with an empty table the first time around. So we're not going to have any options to update or delete since there's no current records, but we can practice adding some new elements. For example, let's get 4 chairs at $50 each. We can add a few more things. Let's say a table, just one. And we'll add a lamp. So now that we've added a few things, we can try deleting some things. Let's delete the table, for example. And maybe we can edit the lamp. We don't want 1, we want 2 lamps. So we can continue to use the interface the same way that we had before. The difference is now the data is going to persist because we're using that storage service. So we've got 4 chairs, 2 lamps. We can close the app, and when we reopen it again, it's going to contain the same data it did the last time we used it. Here we go, 4 chairs, 2 lamps. So I hope you found that helpful, and if you have any questions, please let me know. Otherwise, I hope you enjoyed this video series. This is going to be the last one for the term. It was a lot of fun covering these topics, and I hope you enjoyed them too. So have a great day.